Greetings to all. Today we are going to explore the historical journey and evaluation of neural network. We will look how simple biology concept transferred over decade into the powerful artificial intelligence and deep learning system we use today. Let us begin with the basic introduction to what neural network actually are. To introduce the concept, neural networks are deeply inspired by biological structure of human brain. They form the backbone of a modern artificial intelligence. They primarily function to process large volume of inputs and automatically learn complex patterns directly from data. Let us go back to where it is started, the biological inspired of the 1940s. In 1940s, researchers began designing computing algorithms model after human brain cells or biological neurons. They focused on the mapping out core neural component. Specifically, look at how dendrites receive signals, the axon transmit them, and synapses from the connections between nodes. Based on the biological model, the very first mathematical neuron was built in 1943. In 1943, the McAlopids neuron was introduced as world's first artificial neuron model. This model was highly simplified and operates slightly on binary inputs and binary outputs, meaning zeros and ones. Even though it was basic, it served as a ultimate foundation of neural network. 15 years later, this model is evaluated into a learning machine is called a perceptron. In 1958, Frank proposed the perceptron models. This was a single layer neural network architecture. It introduced adjustable weight and was successfully used to solve the simple linear classification task. It's initially successful. Early researchers soon its major technical road. These early single layer models have certain limitations. Most importantly, they could not solve the non-linear problems. A classical example of failures in famous XR problems, because a single layer could not handle non-linear decisions boundaries. Academic instructor died down, leading to this massive decline in neural network research during this first AI winter. This limitation was finally shattered in 1980s with introductions of multi-layer network. The 1980s brought the massive breakthrough with the multi-layer perceptron. Researchers has overcome the non-linear barriers by introducing intermediate hidden layers between the input and output stages. Along with hidden layers, the backpropagation algorithm was popularized, which allowed network in learn from errors by passing corrections backward. This allowed a system to solve highly complex nonlinear problems efficiently. As we enter 1990s, several category factors has accelerated this field even further. The 1990s marked a major revival period of the neural network. This resonance was driven by three main factors. First, there arrived of significantly better computation power and hardware. Second, the development of improved, the more stable training algorithm. And third, the initially availability of large digitalized data. This computational based paved the way of the deep learning era in 2000. In the 20s, we officially entered the deep learning era. Instead of shallow architectures, researchers began to build deep neural networks. By stacking multiple hidden layers, these networks could extract incredible abstract futures and their own, resulting in unpredictable and accuracy across the various complex. Let's take look at specifically variations of domain the modern landscape today. Today, modern neural networks have evolved into highly specified variation. We have the convolution neural network, which are optimized for spatial and computer vision tasks. We use the recurrent network, which are designed with a feedback path to process sequentially and time series data. And finally, we have transform which leverage self-attention mechanism to power modern generative AI and large languages. Because of these architectures, neural networks are deployed across the numerous global industries. Looking at real world applications, neural networks are now the dividing forces behind advanced image recognition tools. Real time voice to text speech recognitions, automated medical imaging for medical diagnosis, and spottical target detections for autonomous vehicles. To tie everything together, let us wrap up final conclusions. In conclusions, we can see the neural networks enveloped step by step over decades of research, trials, and breakthrough. Today, it stands as the core foundational technology driven from modern AI globally, and it widely used across the thousands of applications daily. Thank you so much for your time and attentions.